Hello everyone, welcome to Vedantu J English. I'm Diksha Ma'am, your chemistry master teacher. So everybody do let me know in the chat box if I'm clearly visible and audible to all of you or not. Everybody in the chat box do let me know. Yes, students, everyone in the chat box do let me know if I'm clearly visible and audible to all of you so that we can start with the session. Yes, everyone. Ready, very good morning, students. So, yesterday we did chemical bonding, right? And today is the day for coordination chemistry because my health was not fine. So, I was not able to complete it in one day. So, that's why I am taking your class today as well, right? Okay, yes, everyone. Shall we start? Shall we start with the class? Okay. So if there is any doubt in the previous session, you can ask me here, right? And those who have not watched it, go and watch. The previous live session was of chemical bonding only, and we have covered it in detail with the PYQs of 2026, right? So today also the criteria is same, more PYQs and less theory will be like in rapid revision, but PYQs will be more here, right? Let's start. So guys, in the first coordination chemistry, let's talk about Werner's theory, right? What is Werner's theory? So Werner's theory explains the primary and secondary valencies here, right? So if I talk about primary, the concept of primary and secondary valencies here. What is the primary valency? Primary valency is same as oxidation number and secondary valency is same as coordination number, right? Primary valency, if they ask you, that means you need to calculate the oxidation number. How do you calculate the oxidation number? This is X, right? Ammonia is neutral, so this is plus 0. If here you have 3, this is cation, so here you will have plus of 3. So this whole will be equals to plus 3. That means X is going to be equals to plus 3. So answer is primary valency is 3. Secondary valency is coordination number. So how many ligands are connected? How many donating sites you have? You have 6 donating sites here because ammonia is a monodentate ligand. Now you must be thinking that, ma'am, who will tell us whether ammonia has 0 charge, whether it's neutral or -1 charge, ma'am, whether it has 1 donating sites or 2 donating sites? For that you need to go through this chart here. Okay, for that you need to go through this chart here. Let me just explain you that chart here, right? That is about the denticity. If I talk about this chart here, monodentate means one donor site, okay, that means they have only one donor site. In this case, neutral ligands are those like neutral ligands with one donating site. For example, you have ammonia, that is considered as amine, that in the form of ligand you write the name as amine. Okay, you write the name as AMMINE, amine. Then guys, we have water, that is having one donor site on the oxygen. Now you will say, ma'am, but there are 2 lone pairs. There are 2 lone pairs, but donating site is only one because that 2 lone pairs are on one atom only, right? So there is one donating site here as well. Then guys, next is, this is called as aqua. As ligands, the name is aqua. Then carbon monoxide. Wait a minute. I think I should not turn on the AC. Carbon monoxide is CO. That is carbonyl, right? That is carbonyl and it is also neutral. Then pyridine, you will not see it as such, right? You will see ammonia, water and carbon monoxide more, right? And here it is called as pyridine only. Maximum you will see ammonia, water, then carbon monoxide, then azide. Rarely you will see it has -1 charge. Bromine has -1, chlorine has -1, cyanide has -1, fluorine has -1. These have -1 charge. And here The names are, this is called as azido, this is bromido, chlorido, cyanido, fluorido. You know why there is O in the last, in the suffix of all of these? Because negative ligands have ido or O in the last. Okay, that is why the name is azido, bromido, chlorido, fluorido, cyanido. Okay, that's how you name it, right? Then you have monodentate minus one. Further ligands are like hydroxide, that is OH, that is called as hydroxido. Then nitrite, that is considered as nitrito. Okay, this one is considered as nitrito. Okay, that is NO2 negative here. Then you have thiocyanate, that is SCN negative or NCS negative. Okay, so this is called as thiocyanate. This is called as thiocyanate, right? So these are all the names that you must remember, right? Then bidentate ligands means two donating sites they have. So neutral are like you have bipyridine, right? Ethylene diamine is very, very famous here, very important. And how do you write ethylene diamine? You write it like this. Wait a minute. Where should I'll just write it here only. Here I have space, so I'll write it here, right? Ethylene diamine is written as this. This is ethylene. This is CH2, and here you have diamine, NH2, and here also NH2. This is ethylene diamine represented by En, right? It has two donating sites. One is this nitrogen, other is this nitrogen. Okay, overall it is a neutral ligand. This is very, very famous, right? Then you have carbonato, that is CO3 negative, that is called as carbonato. O2 negative is oxo. C2, this is also very famous. This one is also very famous, that is oxalato. Oxalato is 2 carbon here. This is C double bond O. This is O negative. This is also T double bond O, O negative. This is also oxalato. It has two donating sites. One is this oxygen, other is this oxygen. So it has two donating sites here, right? Okay, understood, right? Then guys, in the next we have ethylene diamine. The structure I have drawn. So structure, it is already there, so I don't need to write it here. Guys, here you have ethylene diamine, right? That is ethylene, and there are two amines here, two donating sites. This is oxalato. This and this are two donating sites. Then talking about EDTA, very important. Now EDTA can be mono, bi, tri, tetra, depending upon various things. Now, for example, I have H all over here, right? Now, in this case, there are only two donating sites, so I'll call it as bidentate. If I erase this, if I take out this hydrogen, there will be three donating sites, that is EDTA minus 1 will have three donating sites. If I have one more hydrogen, if I lose, it will have two oxygen and two nitrogens, that is four donating sites. So EDTA minus 2 will have four donating sites. If I lose one more hydrogen here, it is 1, 2, 3, 4, 5. Now if you have minus 3 charge, it will have 5 donating sites. Now let's say I am saying that in total what you have, this also you take out 1, 2, 3, 4, 5, 6. Total you have minus 4 charge, and that is hexadentate. That means 6 donating sites are there, right? Okay, tell me how it has hexadentate. Now, ma'am, what if charge is not mentioned and they have just given EDTA? Now see the name. If they have given ethylene diamine tetraacetate ion, that means all of them will have O negative, right? But if they specify that EDTA minus 1, EDTA minus 3, right, accordingly you will tell. If it is minus 3, add 2 here and it will become pentadentate. If it is minus 2, add 2 here, it will become tetradentate. Okay, accordingly you will answer here. Tell me if that is clear. Right? Okay. Hello Abhijit, awesome. I have entered 10th. Awesome, Abhijit. Very good. Right? Yes. Tell me, guys, is that thing clear to all of you or not? Right? Done? Shall I move ahead here? Now we'll talk about that once you know about these, and now let's talk about, instead of chelation, that we'll talk about later on. Firstly, let's talk about, because we have talked about monodentate, tridentate. So now let's talk about this JEE 2023 question that was based on the concept here. They asked primary and secondary valencies of cobalt respectively. Here is what? This is CO, NH3, 5Cl, right? This is Cl2, right? So here it is 2, so here it will be plus 2. That means in the ions, it will split it like this. We'll split it like this. In the ions form, it will be CO, NH3, 5, Cl. This is plus 2, and here it will be Cl negative. Okay. Now, if I talk about this thing here, then here I can say take cobalt as X, ammonia is a neutral ligand, then chlorine is -1 ligand, overall it has +2 charge, okay? So X is going to be +3, that is primary valency is going to be +3, right? Then guys, what about coordination number? Coordination number here, that is secondary valency is 5 and 6. So here secondary valency is 6, so answer is going to be D is the correct answer here. Okay, quite simple, right? Quite simple, everyone. Yes. So now let's talk about the next one here, that is, in this Werner theory only, we talked about one more thing here, that is, if I say 1 mole of this is present. Now, if I say it gives us 3 AgCl, that means in this case 3 Ag will be outside. Okay, so I'll just write it here. In this case, if I talk about this thing here, right, if I talk about this thing here, wait a minute. Wait. So if I talk about this thing here, 3 moles of Ag are formed, that means 3 Cl are outside. Okay, now you have cobalt. How many ammonia you have? 6 ammonia you have, right? And 3 chlorine you have used the 3 chlorine outside this, right? So that becomes, this is the formula here. What about if 2 moles are outside? I'll say 2 Cl are outside. This is cobalt. Cobalt has 5 ammonia and 1 Cl. Total 3 chlorine I have adjusted, out of which 1 is ligand and 2 are counter ions, right? Then if I say 1 mole is outside, 1 Cl is outside, this is cobalt, this is ammonia. How much ammonia you have? 4 and 2 Cl2. So both of these will have the same formula. But the question is, ma'am, why they have different color? This is green and this is violet. This will be based on the isomerism, right? Because of their different spatial arrangement, they will be different isomers, and that is the reason they will have different colors here. Okay, that we will study in isomerism. Okay, understood? Tell me. Done? Okay. Now, same thing I have written here, that here if I say 3 chlorines are outside, that if I say 3 AgCl were formed, 3 chlorine were outside. 2 AgCl mean 2 chlorine were outside. 1 AgCl mean 1 chlorine is outside. If no AgCl is formed, that means all the chlorine are inside. Okay, that's how we write the formula here. So now let's see JEE 2026 question based on that. That says, consider a mixture X which is made by dissolving 0.4 mole of this compound and 0.4 mole of this compound. So two compounds are given to us. Both are 0.4 mole. This is 0.4 mole and this is also 0.4 mole. Okay. To make 4 liter total, it will become, when 2 liter of mixture S is allowed to react with excess of Ag, okay, there is a mixture X which is 4 liter, which is made up of 0.4 of this, if I say this is A and if I say this is B, okay, 0.4 of A plus 0.4 of B, okay. Out of this, I am saying that you are taking out 2 liter. If you take out 2 liter, that means you will take out 0.2 of A, 0.2 mole of B, right? Because half of it you will take out, right? When 2 liter of X is allowed to react with excess of AgNO3, when A reacts with AgNO3, it forms precipitates Y. Okay. What is a precipitate Y? See, when this will react, it will give AgBr as a precipitate. Okay, that is Y. When this will react, this will give Z as a precipitate, reacts with excess of BaCl2, so barium will react with SO2 and it will give Z as a precipitate, that is BaSO4, right? That is the precipitate. Now they are asking that which of the following statement is correct. So see, if one SO4 is outside, here one Br is outside. If I use 0.2 mole of A, then 0.2 mole of X will be formed. Here 0.2 mole of Y will be formed here. So that means X and Y both will be 0.2 mole. Okay. Now they are asking that which of the following statements is correct here. Y is BaSO4. No. Y is AgBr and Z is BaSO4. So this is not correct. Now 0.4 of this is formed, 0.1 no. 0.2 of Z and 0.2 of Y is formed. So answer will be C is the correct answer here. The way of asking it is different. Otherwise it's a very simple question. Okay, tell me. Tell me, is that clear? That works for all of you? Tell me. That works, guys, right? So that is your latest JEE 2026 question here, right? Next, let's see. A chromium complex, again JEE 2026 question here, right? They are saying a chromium complex with formula that is CrCl3.6H2O has spin only magnetic moment this. Its solution conductivity corresponds to 1:2. Okay. See, if I say its solution conductivity is 1:2, that means 2 Cl are outside. Okay. This much of complex solution was initially passed to a cation exchange. The solution obtained after the process was reacted with excess of AgNO3. The amount of AgCl formed in the above process is what? Okay. Yes, everybody, tell me. Shall we see this question? Ma'am, not clear. This was not clear. Okay, I'll just explain this again. Array, nothing. They said that you have a mixture X. Okay, that is formed from 0.4 of this solution and 0.4 of this particular compound. Okay, they both are 0.4 and 0.4. Then they are saying that you have taken out 2 liter of that mixture. If out of 4 you take out 2 liter, that means out of 0.4, 0.2 will be there. Out of 0.4, 0.2 will be there. So that means the mixture out of X, the amount that you are taking out is 0.2 of A and 0.2 of B. Now they are saying that what is X and Y? They are saying this A solution is giving Y precipitate. This B solution is giving, this is giving X precipitate. Wait a minute. This is X, this is Y now. My bad. This was not supposed to look like this. Wait a minute. This will be, A is giving what? A is giving Y as the precipitate and B is giving Z as the precipitate. Okay, so now I am saying that this is giving Y, this is giving Z. Here Y will be what is outside, that is Ag will react with Br. In this case, you are reacting this solution with BaCl2, so Ba will react with SO4. It will give you BaSO4. So Y is, we can say Y is AgBr and Z is BaSO4. So that statement is wrong. Okay. then how much amount of precipitates are formed? See, if only one Br is outside, only one Br is outside here, that means only if I use 0.2 of A, 0.2 of I is formed. Here also only one SO4 is outside. If I use 0.2 of B, only 0.2 of Z will be formed here. Right? Okay? Tell me. That is clear? Tell me. That is clear? Tell me, guys, is that clear or not? Is that clear or not? Done? Chalo. Now let's understand this question here. That is a mixture of mole concept and coordination chemistry asked in 2026, this year, right? Jan attempt. So see, a chromium complex with formula, they are saying this is the formula, right? Has spin only magnetic moment of this, and solution conductivity is 1:2. 1:2 means, if I say 1:2 means if this is the coordination complex, then 2 Cl are outside. If from this formula 2 Cl are outside, that means 1 Cl will be inside, right? If I say this is chromium, chromium can have maximum of 6 coordination number. That means 5 water will be inside. That means out of this 6 water, 1 water will be outside. Tell me. Now, firstly, this thing should be clear to you that this is the formula. Right? This is just one part of this question. Firstly, are you clear on this? How this became the formula? You have, they are saying 1:2. Right? From 1:2, that means 2 Cl has to be outside. Only then after ionization, this will be one part and this will be ratio of 2 because of this. Okay? Now, if I see this here, that is the reason if I put 1 Cl inside, then rest of it will be water. That means we are left with one water that I'll take it outside as a water of crystallization. Okay. Now they are saying the value of magnetic moment is this. That means the number of unpaired electrons. Number of unpaired electrons is going to be 3. We have to see this here if they are 3 or not. If this is 2, this will be +2. So I can see oxidation state is x plus 0 minus 1 is equals to +2. That is x is equals to +3. Now if I see chromium here, chromium is actually 4s1 3d5. You take out 3 electrons from here, it will become 1, 2, 3. This will become 3d3. Okay, 3, 4, 5, 6. I know 2 you will take it there, it will become 3d3. That is number of unpaired electron will be 3. Because Cl and water both are weak field ligands, so there will be no pairing. That we will discuss further in VBT theory as well. But I am explaining you here only that how you can verify that your answer is correct here. That number of unpaired electrons are coming out to be 3 only. That is also correct. Okay. Now he is saying that this much gram of complex was initially passed through a cation exchanger. The solution obtained after the process was reacted with excess of AgNO3. Right? So first thing is what we are doing here. We have this compound here, that is we have CrH2O5Cl, CrH2O5Cl, this is Cl2, right? Water, right? Now here we are saying that this is reacted with AgCl here, right? AgNO3 you have reacted it with, right? Then they are asking you how much amount of AgCl is formed here, right? Firstly, you have to balance this equation here, right? So firstly, let us balance this equation, everyone. Let us balance this equation. Okay, firstly, you need to balance this equation here, right? we are saying that the solution of complex will initially pass through a cation exchanger, right? The solution obtained after the process was reacted with excess of AgNO3. See, now see one thing here. If two chlorine are outside, right? See one thing. If two chlorine are outside, that means for sure 2 AgCl will be formed here, right? That is the only possibility. So if 2 Cl are outside, that means 2 AgCl will be formed. Now they are asking you a simple question, the amount of AgCl formed in the above process. Molar mass of chromium, chlorine, Ag and all of this is given to you. So what you have to do here, first you have to calculate the number of moles of, let's say this compound is A. Number of moles of compound A, that will be equals to number of moles of AgCl will be 2 into number of moles of A, right? Then the molar mass, mass of AgCl will be number of moles of AgCl multiplied by molar mass of AgCl. That's how you will calculate this. That is properly mole concept here. Okay, so I'll just directly give you the answer here. This is 266 point, wait a minute, this is 266.5. Okay, so here it is given to be 2.75, right? 2.75 of this 266.5, and when you solve this, number of moles of this compound is going to be 0.0103. Okay, now number of moles of AgCl will be 2 into 0.0103. Okay, after this you will do this 2 into 0.0103 multiplied by molar mass of AgCl, right? That is coming out to be 143.5. Okay, and hence you will have your answer as 2.96. Okay, so here I am not doing any calculation. I am just telling you how to do this, right? Okay, tell me, is that clear? That is a pure combination of mole concept, and that's a pure combination of mole concept and coordination chemistry, right? Okay, cation exchanger, you can ignore that for now. That is just for your confusion, right? You can say that cation exchangers, basically we want to say that you want to take it out. Okay, this and this solution you want to dissociate. Okay, so just you can ignore that as well, right? Tell me, is that clear what we have done? First you should know, you should get an idea about the compound, then you should verify that your compound is correct or not, and after that if 2 Cl are outside, that means 2 AgCl will be formed here, right? So number of moles of this you will calculate, number of moles of AgCl will be 2 into that, and mass will be number of moles of AgCl multiplied by the molar mass, right? Okay, yes. Okay, let's see. Now let's talk about ambidentate and flexidentate ligands. Okay, now ambidentate ligands, guys, if you have any confusion you can re-watch this, right? Don't ask me, ma'am, can you please repeat the whole thing? After that I have devoted my 10 minutes to that question, right? Okay, you can ask me a part, ma'am, I was not able to understand this particular portion. In complex formation, what you were not able to understand? Tell me what you were not able to understand. Firstly, you don't see what I am teaching, you don't hear properly, then you ask me to repeat it. That's not good. Okay, so but I am repeating for you, but after this you have to be fully attentive, right? So here, which a simple thing is, they are asking me 1:2. 1:2 means 2 chlorine has to be outside. Only then this is 1 and this is ratio 2. If 2 chlorine are outside in this formula, you have 3 chlorine, that means 1 chlorine will be inside. Because in total, you can only have 6 coordination number of chromium. So 5 water will be there and 1 water will be outside, because in total you have 6, 1 water will be outside as water of crystallization. Okay, my throat is already paining, right? But still I am teaching you. Yes. Now let's see this. Ambidentate ligands. Ambidentate ligands are the ligands which has two donating sites, but at one point only one donating site will work. For example, you have SCN, you have NO, you have CO, you have NO2. Okay, all these are ambidentate ligands which have two donating sites, but at one point only one donating site will be able to work here. Right? Okay. Flexidentates have two or more donor coordinate with ligands having two or more donor atoms coordinate with metal atom either through one donor atom forming non-chelated complex or through donor atom forming chelated complex. They are saying that flexidentate ligands are like, I can also make chelated complex, I can also avoid chelating complex, right? It's your choice what you want to do. I am flexible in that context. That is flexidentate ligands. Now, what is, ma'am, chelation? Chelation is actually when you have bidentate ligands and when they donate from their donating sites, right? Bidentate or more than two donating sites which they have, right? They will form a ring here. Like here it is 1, 2, 3, 4, 5 membered ring. Here also, if you see, it has only two donating sites, but it has two donating sites, but at one point only one can donate here, right? So I can see this over here that it is not going to form any ring here. So ring formation is there in oxalato, it is there in ethylene diamine which forms ring, right? Okay, that is called as chelation, and chelation rings, because of the rings, it makes the compound very stable. Okay, so chelation compounds are quite stable, right? Now let's understand IUPAC naming, guys. Let's understand IUPAC naming. Let's understand IUPAC naming. So these are all the points of IUPAC naming that you must remember. First is the cation is named first in both positively and negatively charged coordination entities. So what we are saying, the cation is named first, right? Always there will be, firstly I'll name cation, whether it's coordination complex or it's counter ion, I'll always name cation first. Then the ligands are named in alphabetical order. Ligands will be A, B, C, D according to alphabetical order, I'll name it. Then names of the anionic ligands end with O. That's why it's chlorido, bromido, oxalato, right? But those of neutral ligands, they have specific names. For example, water has aqua, right? Ammonia has amine. CO has carbonyl, okay? NO has nitrosyl, okay? Then you have prefixes mono, di, tri are used to indicate the number of individual ligands in the coordination entity. They are saying that, for example, you have two ammonias, you will say diamine. You have two aqua, you will say diaqua. You have three aqua, you will say triaqua. You have four aqua, you will say tetraaqua. But if you have two ethylene diamine, you will not say diethylene diamine. If in the ligand itself you have di or tri or something, in that case you will mention 2, 3, 4 by this thing. That is bis for 2, tris for 3, tetrac is for 4, pentac is for 5, hexac is for 6, okay, accordingly, right? Oxidation state of metal in the cation and anion-neutral entity is indicated by Roman. Okay, in the bracket you will have Roman numeral, right? Then if the complex is cation, then it's fine. The name will be as it is. But if the complex is a anion, in that case, the name of metal ends with the suffix ate, like cobaltate, ferrate, argentate for silver. Usually silver has, if the complex is cation, silver has a name silver. But in case of anion, silver will be written as argentate, nickelate, chromate. Okay, that 8 you will put in the end. Neutral complex molecule is named similar to that of complex cation. Let's see some important names here, right? If you see this over here, in this case, first I'll talk about this one. See, if here you have 3, that means here you should have +3. Okay? Now this is the cation, so I'll name the cation first. In the cation, whenever you write the coordination entity, first you will write ligands. This is amine, this is aqua, so I'll write amine first. 3 amines are there, so I'll write triamine, triaqua, chromium, because coordination entity is cation, so I'll write chromium simply. Now chromium, what is the oxidation state here? This will be X plus 0 plus 0. This is over here +3, so I'll write equals to +3. So oxidation state is +3, and counter ion simply you can write, don't write trichloride, no. Right, counter ion, you will not write di or tri, you will simply write the name of the cation or anion. This is chloride, so simply write chloride. Chlorine as a ligand, we write it as chlorido, but as a counter ion, it is chloride only. Okay? Then let's talk about this one. In this case, you will have, this is SO4 thrice, so here you will have +3. Now in this case, the ligand is ethylene diamine, as you can see, and there are 3 ethylene diamine. That means I'll write I'll write tris. Why? Because ethylene diamine only has di in the name, so I'll write tris bis tetrakis here. So this will be tris ethane 1,2-diamine or ethylene diamine in the bracket, right? Then I'll write cobalt. And what is the oxidation state? X plus 0 is equals to +3, because ethylene diamine is a neutral ligand. So this is 3. Then this counter ion is sulfate. Okay. What about this one? This is when you have 2 coordination brackets. Okay. This is when you have 2 coordination brackets. In this case, what we will do? We'll have AgNH3 twice, AgCN twice. So here in this case, firstly I'll write cation. This will be +1, this will be -1. Okay. Now, why this is +1? Because here X is coming out to be +1. This is X minus 2 is equals to -1. X is coming out to be +1, and silver is stable in +1 oxidation state. That is why I can put overall charge as +1 -1. This is cation, so I'll write diamine silver. Diamine silver, oxidation state is 1. This is dicyanido, but here the metal is in the coordination bracket, that is anion. That is why metal is named as 8, that is argentate. So this will be argentate 1. Tell me. Clear? Tell me, is that clear? Is that clear, guys? Tell me. Is that clear? Now I'll see. So many things we have, right? Now we'll start with VBT. Now we will start with VBT. Okay, the major part of where the questions are asked. Okay. Very good, Anjali, absolutely correct, right? So here now let's talk about VBT, that is valence bond theory. Now in case of valence bond theory, what you will have? In case of valence bond theory, right, I'll just directly tell you this thing here. Wait a minute. Okay, this I'll do after, this will not do here. I'll do this here. Okay, VBT you can start from here. That question I'll tell you, but later on. Wait a minute. VBT, valence bond theory. In valence bond theory, how you will solve it? If coordination number is 4, either it can have sp3 or dsp2 hybridization. If coordination number is 6, either it can have sp3d2 or d2sp3 hybridization. Okay. If it is sp3, it is regarded as tetrahedral. If it is dsp2, it is square planar. sp3d2 is octahedral, outer octahedral, and d2sp3 is inner octahedral. Now one by one I'll explain how to solve this. Okay, you can't cram these things. Okay, you need to understand how to solve this thing in the exam, right? Because a lot of questions are asked based on VBT. See this. We have NiCO4, right? So firstly, what you will do, first you will calculate the oxidation state. X plus 0, this is the neutral ligand, is equals to 0. That means nickel exists in 0 oxidation state. No electrons we take out from here. This is 4s2 3d8 is the electronic configuration of nickel. Okay. Now, similarly, I'll calculate the oxidation state here. This is X minus 4. Chlorine is 4, minus 1, so it is minus 4 is equals to minus 2. So X is going to be plus 2. Nickel exists as 4s2 3d8. Now nickel 2 positive is 3d8. Okay. Till now, first work is to understand what is the oxidation state and then write the electronic configuration of that cation or metal, right? Now see, if I talk about this thing here, coordination number is 4. That means 4 empty we need. 4 empty we need. So I'll write it here. Firstly, D, 1, 2, 3, 4, 5. Right? This is S and this is P. Similarly, here I'll write D, 1, 2, 3, 4, 5. Now, CO is a very strong ligand. It will always, it is the most strong, even stronger than, you will see the spectrochemical series, right? In CFT, we'll learn about which one is strong, which one is weak, right? That we will see here, right? CFT. Actually, what happens, we use the crystal field theory here as well. So many questions I am going to teach you, see? So many questions. Yes. If you see this here, this CO, this is a spectrochemical series. This always behaves as strong field ligand. This is a very strong field ligand, maximum strength, right? So that is the reason here whenever there is a strong field ligand, what we do, we cause pairing here. So 1, 2, overall you have 10, 8 plus this 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's how you write it. Overall pairing will happen here. So in the end, you will have 4 empty, that is sp3 hybridized orbital. That is why first thing is it is tetrahedral in nature. It has sp3 hybridization. Number of unpaired electron is 0, so mu is also equals to 0. If there is no unpaired electron, magnetic moment is also 0 here, right? Now we say that it is a low spin or high spin. Low spin, there is 0 unpaired electrons here. So low spin complex, or you can say spin paired complex. Spin paired complex. You can also write it as spin paired complex. And if there is no unpaired electron, you can also write it as it is diamagnetic. Okay, they can ask you any of these things in the exam, right? What about this thing again? If you see this 8, now Cl is a weak field ligand, so no pairing. So 1, 2, 3, 4, 5, 6, 7, 8. Here again the hybridization is again sp3, same tetrahedral, but number of unpaired electron is 2. Now understand one thing, whenever you talk about number of unpaired electron, for 1 it is 1.7 magnetic moment, 2 2.8, 3 3.8, 4 4.9, 5 5.9. So for 2 we will have the magnetic moment directly will be 2.8. Unpaired electrons are there, so that is why it is called as paramagnetic. Okay, it is a high spin complex, or you can say spin free complex. Spin free complex. Okay, now that was about coordination number 4. If I talk about coordination number 6, how I define it? See, again I'll do the same thing. I'll calculate the oxidation state. That is, I'm just telling you how to solve this. Okay, This is x minus 6 is equals to this, x is going to be equals to plus 3 here, right? Here it is x minus 6 is equals to minus 3, x is going to be plus 3 here as well, right? So what you need to do here, iron, that is 4s2 3d6, 26 is atomic number, iron plus 3 will be 3d5. Here also iron plus 3 will be 3d5. Now here what you will have D 1 2 3 4 5, S, this is P, again this is D, another, this is outer D. Okay, here also you will have D, okay, then S, then P, then another D. Okay, wait a minute. Yes. Now fill the electrons, 5 electrons. This is a strong field ligand, so it will cause pairing. So it will be 1 2 3 4 5. So there will be D2sp3. Hybridization will be D2sp3. It is inner octahedral. Inner octahedral. Number of unpaired electron is 1. Mu is equals to 1.7. So that is why it is again paramagnetic. Here there is no pairing, so I'll take it as 1 2 3 4 5. So here it is sp3d2, that is outer octahedral. Number of unpaired electron is 5, mu is equals to 5.9. This is also para. Tell me, is that clear? Okay. Now see 1 2 more things here, right? Now let's see what kind of question they ask you from here, right? I'll start with this question, that is 2026 question here. They ask you, now lot of questions will do from VBT, how they ask you the questions, right? Okay, let's talk about that. The number of species among SF4, NH4 positive, NiCl4. Now they are saying that have tetrahedral geometry are 3. Okay. See, in this case SF4 it had seesaw geometry, so we discussed it in chemical bonding. This is not correct. This has tetrahedral, that is correct here. NiCl4 we have just discussed, it was tetrahedral geometry. We have just discussed this here. It was tetrahedral, right? So I can say this is tetrahedral, right? XCF4, you remember in chemical bonding I discussed about XCF4. Xenon is how much? Half. Valence electrons are 8 plus 4 monovalent. So 8 plus 4 is 12 by 2. That is 6. It is hybridization is not sp3. So how can it can be this hybridization is octahedral, so sp3d2, so this also cannot be true. In this case platinum, if you talk about the coordination number here, now in case of platinum always remember that in this case you will always cause pairing, no matter it is weak or strong field, it will always cause pairing. So this is also not correct. In 4D and 5D elements, 4D and 5D, even if you have weak field ligand, it will always cause pairing. It will always cause pairing. Okay. So that is why this also cannot be, this will become DSP2. Selenium, in this case, if you talk about the oxidation state, this is half. Selenium 6 outermost and this is 4. This is 10 by 2, that is 5. Again, no. 5 is sp3d. It cannot be tetrahedral. What about this one? NiCN4 2 negative. NiCN4 2 negative, we have discussed this here. That Ni, even if you have here, let's say there is pairing 1 2 in this case you have, if you say, let's say there is NiCN here, so 8 electrons will be there, 1 2 3 4 5 6 7 8, this will be dsp2. So this is also not tetrahedral. Okay, this is also not tetrahedral, so only one species there, that is tetrahedral, so it is a false statement. Then in the set of this, all the molecules have incomplete octet around the centrimetal atom. All of them have incomplete octet. This one to have, this one also have, right? This also has odd electron species. NO2 is a odd electron. Ma'am, if strong, wait a minute. Ma'am, what is cross pairing? But firstly, let's see here. Okay. Now, in this case, you have odd electron. That is why it is octet is not complete. Okay, that is also true. BeH2 also has only 4 electrons. Octet is not complete. That all of them has incomplete octet. So that is true. So I can say statement 1 is false and statement 2 is true here. So answer will be C is the correct answer here. Is that clear? Okay, tell me. Is that clear, everyone? So that is your JEE 2026 question. Chemical bonding they have asked. They have asked in between the structures as well. They have asked the coordination chemistry questions also. So in one question they have asked multiple things here. Next question is 2026 question itself. They are saying among the following, CN and Cl you have to tell. Okay. So see, if I talk about NiCN, this I have told you multiple times. If you put Cn here, if here you have weak field ligand, there is no pairing. If here you have strong field ligand like Cn, it will be 1, 2, 3, 4, 5, 6, 7, 8. One of them will be empty. That will become DsP2. That is why we are saying if you have NiCN4, in that case, it will become both are diamagnetic or not. See, this is going to be diamagnetic and this is going to be paramagnetic because of unpaired electrons. So this is not correct. NiCO is diamagnetic, Ni this and this are paramagnetic. No, this is also diamagnetic. This is also not correct. This and this are diamagnetic. No, this has unpaired electrons, so this is not diamagnetic. NiCO and NiCO4, they are diamagnetic. This is definitely diamagnetic. No unpaired electron was there. This also all pairing happened, so this is also diamagnetic. This is not diamagnetic. This is para. So answer will be D is the correct answer here. Okay, understood? So this is again your latest question, attempt 1. So this is a quite scoring chapter only, right? Now next question is this one. If you see JEE 2026 question here, again they have mixed coordination with the chemical bonding. Hybridization, shape and spin only magnetic moment of K3CO3 thrice is what? Okay. So if I talk about K3CO3 thrice, this one. Calculate the oxidation number. This is 3. This will be minus 3 here. This is X minus X plus minus 2 is charge on this, and this is 3. It is equals to minus 3. X minus 6 is equals to minus 3. So X is equals to plus 3. Cobalt is 4s2 3d 7, 27. Cobalt plus 3 is going to be 3d6. Okay. Now you need to have 6 coordination, 6 see, one carbonato has 2 donating sites, so 3 will have 6. So coordination number here is going to be 6. Okay. So that is the reason here you will have B. Okay, this is S and this is P. Okay, understood? Now tell me, will there be any pairing or not? Yes, everybody? Will there be any pairing or not? There is 6 unpaired electron. So 1, 2, 3, 4, 5, 6. So it will have sp3d2 hybridization. Because carbonato is not a strong field ligand that it will cause pairing. It will have sp3d2, right? Now here they are saying this is sp3d2, that is correct, it is octahedral. Number of unpaired electrons are 4, so magnetic moment is going to be 4.9, that is correct. So this statement here is correct here. I can say this statement here is correct. Okay. What about this one? Geometry, hybridization, spin only, magnetic moment of these three are going to be what? Okay. So you have to tell NiCN. See, NiCN, so I told you already, we have discussed this, NiCN for 2 negative. In this case, you will have, this is pairing will be there, so dsp2, number of unpaired electron is 0, so mu is also 0. So dsp2 is the hybridization, 0 is the magnetic moment, geometry is square planar, that is correct. So for first compound everything is clear, right? What about MnBr4 2 negative? What about MnBr4 2 negative? What about this? MnBr4 2 negative. This is going to be what? In this case, firstly again you will solve this oxidation state, that is x minus 4 is equals to minus 2, x is going to be plus 2. Right? Manganese is actually 4s2 3d5, right? Manganese 2 positive is nothing but 3d5. So Br is a weak field ligand. So what you will have? 1, 2, 3, 4, 5. This will be there in the D, right? And 4, this will be sp3. So that means S and p3 will be left behind. So you will have sp3 as the hybridization. Mu is going to be what? sp3 hybridization. It is going to be tetrahedral. Mu is going to be 5.9. Let's see. So you have mu as 5.9, sp3, and that is tetrahedral. For this also it is true. COF6 3 negative. COF6 3 negative I have also calculated here. No, that we have not calculated. COF6 3 negative, okay? COF6 3 negative, let's talk about that. Oxidation number +3. Cobalt is nothing but it is, you take out 3 electron, 3d6. Weak field ligand, again no pairing, so it will be 1, 2, 3, 4, 5, 6. Okay. So it will be, we will be left with sp3d2. Unpaired electron is 4, so mu is also 4.9. Okay. Mu is 4.9, sp3d2, and that is octahedral. This whole is true. Okay. So you can say both the statements are true. Both 1 and 2 statements both are true here. Right? You can see they are asking you the same kind of question, but they are right now making it little lengthy. Either the question is complicated or the question is lengthy. I would prefer lengthy questions, but at least you will get the answer, right? Okay, done. How sp3, ma'am? Bacha, because, oh, you want me to draw it? Beta, how much practice, huh? Very less practice, kya? This is S, this is P. 4 coordination state. 1, 2, 3, 4, 5. You are left with sp3 here. Very less practice, kya? Is it? Practice more. Let's see. Next is 2026 question, that is statement 1 is the number of paramagnetic species among these are 3. Paramagnetic species, again 2026 question, that is again statement based question they are asking you. In those statements they are asking you lot of things. Okay? Acha, yes ma'am. Okay Anjali, good. Right? Now see, lengthy questions are there. Right? So The number of paramagnetic species you have to tell here. If you talk about this one, this we have calculated just now, COFe63 negative. COFe63 negative, that was paramagnetic for sure, right? Okay. Then what about titanium F6? Titanium F6, how you will see? X minus 6 is equals to minus 3. That is titanium plus 3. Titanium is what? 4s2 3d2. So titanium plus 3 will be 3d1. So it will always be paramagnetic. One unpaired electron will always be there, whether it's strong field or weak field. It is weak field, so it is one unpaired electron is there. So this is D1. This is what? This has how many unpaired electron? 1, so it is 1.7. This has how many unpaired electron? 4, so it was 4.9. Here we have discussed that, right? It had 4 unpaired electrons, so 4.9, right? Okay. What about this one? Vanadium oxide here. Yes, everyone. What about vanadium oxide? Everybody, tell me. What about vanadium oxide? Tell me, vanadium oxide, this is 2x minus 10 is equals to 0. So x is equals to plus 5. Vanadium is what? Vanadium is active. 4s2 3d3. You take out 5 electrons, vanadium plus 5 will become d0. So D0 always will be diamagnetic no matter what. So it is diamagnetic. Number of unpaired electron is 0. Okay? Because it is always D0. Because configuration is D0. Okay? So this statement is false here. Achha, they are asking paramagnetic. Wait a minute. Let's just see this one. If you see FeCN6, so I have calculated this here, FeCN6. Okay? Because what I have calculated, why I will do it again and again. Okay? This has one unpaired electron, that is also para. Okay, so I can say this is also para. This is also para. Number of unpaired electron is 1, that means mu is equals to 1.7, so it is also para. So 1 para, 2 para, 3 para, so this statement is correct that it has 3 paramagnetic species. What about this one? They are saying that the correct order in terms of unpaired electrons. Now this is based on the strength here, right, of the ligands, ligand strength. Ligand strength will do it further. Correct order in terms of number of unpaired electrons they are saying. Okay. Okay, let's do this. So if I talk about this thing, this is 3, this will be plus 3. This is 1, this will be plus 1. This is 0, this is 3, this will be minus 3. This is 4, this will be minus 4. Okay, so one by one I'll calculate all of them. So I'll divide it into 4 parts, right? So if I see the unpaired electrons, let's see if we can see that or not. If you see this one, here it is x minus 6 is equals to minus 4. That means it is in plus 2 oxidation state. This is x minus 6. This will be in plus 3 oxidation state. This is 0 only. This will be in plus 1 oxidation state. And here this will be in plus 3 oxidation state. So iron only you are calculating. We know that iron is nothing but it is 4s2 3d6. So first is iron plus 2. Iron plus 2 will be 3d6. This will be iron plus 3. That is going to be 3d5. Here also it is iron plus 1. That is going to be 4s1 3d6. Okay. Wait a minute. here it is, wait a minute, if overall here SO4 is 2 negative, so here it will be plus 2. My bad. Okay, this will be plus 2. Because if here overall, if you see cross multiplication, this actually is minus 2. So this has to be plus 2. Only then this is 1 and this is also 1. So here it will be plus 2 here, right? And that is why this will be plus 2. So iron plus 2 is nothing but that is, we have discussed 3d6, and here it is iron plus 3, that is 3d5. Now you will see this here, that in this case you have strong field, weak field, weak field. So here you have strong field, here you have weak field, here you have weak field. Strong field means it will cause pairing, so it will be 1, 2, 3, 4, 5, 6. So unpaired electron is 0, mu is equals to 0. Here strong field means 1, 2, 3, 4, 5, okay. 1, 2, 3, 4, 5. So number of unpaired electron is 1, mu is equals to 1.7. Okay. In this case, number of unpaired electron is, it is weak field ligand, so it will be 1, 2, 3, 4, 5, 6. So number of unpaired electron is 4, mu is 4.9. This is 1, 2, 3, 4, 5 and 5 is there, na? So here you will say that the number of unpaired electron is 5, mu is equals to 5.9. So that also comes out to be the correct answer here, right? Okay. So simply it's not a tough question at all. It's just that little bit time it will take you, right, to solve this, but otherwise you can directly also do it, right? Okay. Next question is again JEE 2026 question, that is based on identify the correct set of details from the following, right? So you can see in almost every shift they have asked question based on VBT. So if you see identify the correct set of details from the following, in this case you have to tell about the details. See, firstly NiCN I have done it, right? NiCN4 was actually, you had nickel 2 positive, that was 3d8. You had 1, 2, 3, 4, 5, 6, 7, 8. You have DSP2. So this is sp3 hybridized, that is incorrect. It was DSP2. FeF6, if you see this here, it was here. If you want to calculate it fast, how you will do it? See, this is x minus 6 is equals to minus 3. So iron is in plus 3 oxidation state. See, iron is nothing but 4s2 3d6. Plus 3 means iron will be 3d5. Okay, that you must know. Iron in plus 3 oxidation, that means this is D5 and this is weak field ligand. So it will be 1, 2, 3, 4, 5, right? Then you will be left with sp3d2 only, right? Answer is, this is correct. D is correct, definitely. That is why this cannot be the answer, right? What about CO? Cobalt. Cobalt in plus 3 oxidation state will be what? Cobalt will be 4s2 3d7. In plus 3 oxidation state, it is 3d6. So 3d6 in weak field is 1, 2, 3, 4, 5 and 6. So here again you will have sp32 and they are saying d2 sp3, that is incorrect. So C cannot be the correct one here. So whenever you see C here, that is incorrect. C here, that is incorrect. Answer will be D is the correct answer here. Okay. That's how you define the answer. But if you want to calculate this and this as well, you can do that, right? This is, I talk about cobalt with NH3, right? Cobalt with NH3. This is plus 3 oxidation state. Cobalt in plus 3 is 3d6. Now here you have strong field. This behaves as strong field ligand with cobalt. Okay. So it will cause pairing 1, 2, 3, 4, 5, 6 and you will be left with D2sp3. So answer, because it is like this now. It is like this. Okay. 3 orbitals of D are already filled. You are left with 2 orbitals. So it is D2sp3 as the correct answer. Okay. Then MnCl6. Manganese is X minus 6 is equals to minus 3. Manganese is in +3 oxidation state. Manganese is this one, +3 will be 3D4, right? So here you have a weak field ligand, so it will be in the D, what you will have 1, 2, 3, 4. So you have one empty orbital. One empty orbital, what you will do with that? Nothing you can do with that. Okay, so one empty orbital is there, but still you will choose sp3d2 here. Okay, so answer is, this is also correct. So answer will be D is the correct answer here. Okay, understood? Tell me everyone, is that clear? So many questions we have based on this. Statement 1, wait a minute, let me just see that. Most of the pages are empty only, don't worry, right? So JEE 2026 next question is statement 1, you have this has maximum number of unpaired electron. Okay. They are saying among this and this. This will have maximum number of unpaired electron. See, if you want to have unpaired electron, there should be firstly no pairing. Weak field ligand should be there. So En is a strong field ligand, that should not be there for sure. Then unpaired electron will not be there. With copper, ammonia also is a strong field ligand, so this is also not correct. You should have weak field ligand. This is also a strong field ligand with nickel, so this is also not possible. So only possibility is actually manganese only. Okay. Only possibility here is manganese only. Wait a minute. Wait a minute. Okay. So only possibility here is if you talk about copper with the ammonia, that also behaves like a strong field ligand. If I talk about this one here, in this case also, let's talk about firstly manganese. Manganese will be in +2 oxidation state. That means manganese will have 3d5. So weak field ligand means it will have 5 unpaired electron. So 5 unpaired electron, definitely it will have maximum only. More than this, it cannot have 5. Why? Because in this case, nickel is in +2 oxidation state, means 3d8. So it can never have 5 unpaired electron, even if strong field or weak field. Right? So that means only possibility is this one, which has 5 unpaired electron here. That means this statement is correct. The number of pairs among this that contains only diamagnetic species are 0. Diamagnetic species, let's talk about that. Diamagnetic, any of them has diamagnetic, you know this, diamagnetic species. This one is diamagnetic species. The number of pair among this that contains only diamagnetic species is 2. Only diamagnetic species. This one is diamagnetic, this is paramagnetic, so this is not. Wait a minute, that contain only diamagnetic species. No, this is actually paramagnetic. This is also paramagnetic. Okay, these two are diamagnetic, this is also diamagnetic. So number of pairs which contains only diamagnetic species is 1. Only this pair here contains 2 diamagnetic species. So that pair which contains only diamagnetic species is 1, not 2. So this is false. So we can say statement 1 is true, statement 2 is false here. Right? Same questions. Can you see that? Same questions are being repeated here. Right? Again, JEE 2026, total number of unpaired electrons present in the central metal atom. Central metal atom, how many unpaired electrons are possible? Let's talk about this. Again, unpaired electrons. Can you see the variety of questions that they have asked in unpaired electron VBT? This is a for sure question. If you don't do this properly, then you're doing a big mistake. I am picking only JEE 2026. There are so many questions of JEE 2026 based on this one concept. right? I think even now you are also bored. I am also bored of solving the same question, but we will solve it because it is latest. We will solve it, right? Total number of unpaired electrons present in the sentimental atom of ions is what? Total number of unpaired electrons. In this case, NiCO, if you remember, this is a strong field ligand. This will be number of unpaired electrons were 0 here. We have solved it. It was actually 4s2 3d8. Total 10 electrons were there. All of them were paired. So number of unpaired electron is 0. In this case, you had 3d8. This is 1, 2, 3, 4, 5, 6, 7, 8. So number of unpaired electrons are 2. Okay. In this case, what you have X minus, platinum always is a strong field ligand, minus 2 plus 0, that is equals to X is equals to plus 2, right? Okay. So in this case, in the case of platinum, let's calculate the number of unpaired electron. Okay. So answer, platinum, if you take out 2 electrons, nickel, and in the nickel only you will have platinum. Basically it will be like this. This will be 4s2. Wait a minute. Platinum is 4s2 5d8. You take out 2 electrons from here, it will become 5d8. Okay. This is a, if you talk about this thing here, in case of 4D or 5D elements, whether you have strong field or you have weak field, it will always cause pairing. So always there is no unpaired electron, that means N is 0 here as well. Okay. What about this one? What about this one? This one is again all of them will cause pairing. This is 3d8, pairing will be there. So number of unpaired electron will be 0, right? In this case also, right, if you see platinum, this is again platinum 2 positive, that is nothing but it is also 4d8, sorry, it is 5d8. Okay, understood? It is 5d8. Now in this case, wait a minute, why I have written 4s, this should be 6s, wait a minute, this should be 6s, okay, so it will be 5d8, right? Now again here there will be pairing, so that is why number of unpaired electrons is going to be 0. So total will be 0, 0, 0, only 2 is the answer here, right? Okay, tell me, is that clear everyone? Is that clear? Is that clear? So unpaired electron is only present in the case of second. Platinum 4D or 5D elements, they, no matter you have weak field, strong field, they will always cause pairing, no matter what you have. So majorly students can do mistake here. They can say, ma'am, here unpaired electron will be present, weak field ligand is there. No. Whether you have weak field or you have strong field, in 4D and 5D, always there will be pairing, no matter what is the ligand. Okay. So answer will be 2 is the correct answer here. Next question is, identify the metal ions among cobalt 2 positive, this and this, having spin only magnetic moment value more than 3. More than 3 means it should be 3.8, 4.9, 5.9. Number of unpaired electron can be 3 or 4 or can be 5. Let's talk about that. So we want number of unpaired electron to be more than that. Okay. So if I talk about cobalt, cobalt is what? 4s2 3d7. So in this case, cobalt 2 positive is nothing but 3d7. So unpaired electron is 10 minus 7, that is 3. That means magnetic moment will be 3.8, which is correct. This lies in that category. Nickel. Nickel is 4s2 3d8. Nickel 2 positive is 3d8. So 10 minus 8 is 2. So this does not lie in that category, right? The sum of unpaired electron present having, they are saying identify the metals having spin only magnetic moment more than the sum of unpaired electron present in the high spin octet formed by these metal ions. First you have to identify the ions. Fe. Fe is what? 4s2 3d6. Fe2 positive is what? That is 3d6. Okay, so that is 10 minus 6 is equals to 4. So this is 4, definitely correct. Now next is vanadium. Next is vanadium. Next is vanadium. Vanadium is T verse, so it is 4s2 3d3. Vanadium 3 positive is nothing but it is 3d2. So 2 unpaired electron does not lie in that category. You need 3, 4 or 5. Titanium. Titanium is 4s2 3d2. You take out 2 electrons from here. This will become 3d2. So definitely no. So answer will be only 2 metals are there. That is cobalt and you have iron, which has more than 3 magnetic moment. Now the sum of unpaired electron present in the high spin complexes, that means when there is no pairing only, right? So you have cobalt. Cobalt is how many electrons are there? 3d7. Okay. Here you have Fe2 positive is 3d6. So number of unpaired electron here are 3. Number of unpaired electron are 3. Here number of unpaired electron are, when there is high spin complexes, means simply 10 minus, that means it will be 1, 2, 3, 4, 5, 6, 7. So 3 unpaired electrons are there. Number of unpaired electrons are 3. This is 10 minus 6, that is 4. Okay. So 4, 5, 6, 7, that means answer is going to be 7 is the correct answer here. Tell me everybody, is that clear? Is that clear everyone? Is that clear? Yes. Done? Okay. So mostly PYQs we have done for 2026. Now there is one question of 2025. Let's see that. The spin only magnetic moment, this I'll give you for homework, okay? This I'll give you for homework, right? Because I know you can do it. Spin only magnetic moment of the compound with strongest oxidizing, no, I'll do it myself. Value of a compound with strongest oxidizing power among all of them. Yes? Yes. Tell me everyone. Everyone, ma'am, N is not used to hear. I didn't get you. What you're saying? Achha, tell me. Spin only magnetic moment of compound with strongest oxidizing power. Out of this, you should know which one has strongest oxidizing power. So this one has strongest oxidizing. I'll tell you how. This is titanium plus 2. This is vanadium plus 2. This is manganese plus 3. Okay. So manganese plus 3. Oxidizing power means manganese plus 3 is actually what? This is a very important question. Okay. So if you talk about this thing here, manganese plus 3 here, what is the oxidation state? What is the this is 4s2 3d5. Manganese plus 3 is 3d4. Oxidizing power means oxidizing agent. If it is a good oxidizing agent, it is itself getting reduced very easily. That means it is easily getting reduced and getting converted to plus 2. Why? Because it is getting converted to a stable oxidation state. Right? Now, because of this stable oxidation state, it can easily decrease its oxidation state. Because here in plus 2 it is existing as a stable oxidation, as a stable electronic configuration D5, so it can easily get reduced. If this can easily get reduced, it is a very good oxidizing agent, right? Okay, so that is the reason this is a very good oxidizing agent. First thing is this one. Second is they are saying spin only magnetic moment of this. So manganese plus 3 is nothing but 3d4. So spin only, number of unpaired electron is 4. So mu is going to be 4.9. Okay, tell me. Is that clear? Is that clear, everybody? Tell me. Okay, they are talking about nearest integer here, so you can write 5. Nearest integer is 5 here. Tell me. Okay, there's some very, very interesting questions. All the questions are quite interesting that I have picked up. Right? Now we will start doing CFT, right? And lot of questions based on that. Let's talk about CFT. Ready, everyone? Ready for CFT? Tell me. CFT. In the crystal field theory, I'll just do rapid revision of your theory part. In the CFT, see, we know that d orbitals are of two types. One is along the axis, other are between the axis. So between the axis are dxy, dyz and dzx, and along the axis are dx square minus y square and dz square. They are along the axis. Now if I talk about octahedral complexes, right? If I talk about octahedral complexes, in this case what you have, in this case octahedral complexes, what you have here, 6 coordination number, and here firstly because of the presence of ligand, all the orbital will increase their energy, and after that in the octahedral complexes, because octahedral complexes are along the axis, right, and the ligands dx square minus y square and z square are also along the axis, because of the repulsion, right, these orbitals will have more energy as compared to these orbitals here. So you call this as T2G and we call this as EG. Okay, this is regarded as EG and this is T2G. Let me just write it here. This is T2G and this is regarded as EG here. This is T2G, this is EG, right? Now, if I say the gap is very large here, that means 1, 2, 3 and 4th electron I have to fill here only. So if the gap is very large, that means there is strong free ligand. That is why the gap is very large. That is why the next electron cannot jump to the next position here. It has to pair up here only. If the gap is not large, I'll do 1, 2, 3 and 4th electron can go here. So we say that, then that is the reason we say this thing, that for weak field ligand, there is, wait a minute. Okay, I'll just write it here, right? I'll just write this here. Weak field and strong field ligand, what else they can write for you? Okay? How they can confuse you in the exam. See. If I say weak field ligand, that means CFSC, gap is low. That means pairing, no pairing will take place. Because the gap is very low, so you can easily jump to the next level, right? That means pairing energy is definitely less than delta O. So, because pairing energy is not that much, so you can easily cause, my bad. The pairing energy is greater than delta O. That means pairing energy is so much high that you are not able to use your money. For example, something is very expensive, right? For example, this is the Eiffel Tower. I have to purchase this Eiffel Tower. This is not possible, but still, let's imagine this is the Eiffel Tower and I have $1 million. I want to purchase this, but still I can't, because the pairing energy, the money to purchase something, like let's say this Eiffel Tower is made up of gold, right? And I want to purchase this, but I won't be able to purchase this. Reason being, because ma'am, it's too expensive for you. Same thing, if something is very expensive, we will not be able to do that. So by pairing energy, we are not able to cause pairing because it is super expensive here, right? Okay. Then this is done by weak field ligand here, right? In this case, you say CFSC. Now this will make, because there is no pairing here, so they will make high spin complexes. Okay. In this case, CFSC will be low. Sorry, gap will be very high by strong field ligand. So you can easily cause pairing because you can't go above, so you will cause pairing only. Pairing energy is less than delta O here. Delta O is so much higher than pairing energy that you can easily cause pairing here. And here low spin complexes, because you are causing pairing, so low spin complexes are formed. Okay, any of these terms they can use here, but you should know which resembles the strong field or weak field ligand here. Right, now if I talk about the wait a minute, yes, I'll just write this here. First thing is, if I talk about these two energies here, if I say here, ma'am, we have Eg and T2G. T2G is minus of 2 by 2 and this is plus of 3 by 5. So that is why we say that the energy of two Eg orbitals are increased by plus of 3 by 5 and T2G are decreased by minus of 2 by 5. Okay. So how you can remember the formula here? Directly you can remember this way. Wait a minute. Directly you can remember just this formula and that will work. Okay. Yes, I think this formula is enough for you. Okay. So how you remember the formula of tetrahedral? Minus N1, this N1 defines the T2G electrons, this N2, this will be plus. This will be plus. Okay, this N2 defines the Eg. T2G electrons, minus of T2G electrons multiplied by 0.4 plus Eg electrons multiplied by 0.6. That is the answer for CFSC here. Okay. Now, if you talk about tetrahedral complexes, things are going to be opposite here. Wait a minute. For tetrahedral complexes, things are going to be opposite here. In tetrahedral complexes, E, that means dx square minus y square, that is going to be below, right? And this will be above. Now here we don't apply G here because there is no symmetry in the tetrahedral complexes, right? Again here this is decreased by minus of 3 by 5 and increased by plus of 2 by 5. Okay. Now let's talk about the questions, guys, that we have. The correct increasing order of spin only magnetic moment values for all these are what? This is the again same spin only magnetic moment they are talking about now. Okay, spin only magnetic moment, this also beta you can do it yourself as well. Tell me if you want me to do this for you. I can see your attendance here and I am so much disappointed by you guys. I'm not going to continue this series, that is for sure. Okay, if you're going to behave like that, then what I am here for, right? You do it yourself only. I mean, literally so much hard work I put for you and you provide nothing in return. So let it be, right? The correct increasing order of spin only magnetic moment values of the complex ions are what? Now you have to define the spin only magnetic moments here, right? So firstly I'll do for this one, manganese. Manganese is actually in +2 oxidation state. Manganese +2 means it is 3d5. Weak field ligand means there is 5 unpaired electrons here. That is going to be the maximum. So A is definitely going to be maximum here. This is eliminated. Let's talk about B here firstly. B is what? This is copper 2 positive. B is actually 4s1 3d10. So it will become D9. Okay. Now it is a weak field ligand. So 10 minus 1 is number of unpaired electron is 1 here. So A is definitely maximum. This part and this part is not correct here. This or this is correct. So if I talk about C here, this is nickel +2. Nickel +2 means 3d8, right? Strong field means number of unpaired electron is 0 here. So C is going to have minimum and D is going to have, this is nickel again. Nickel is again 3d8, but weak field ligand means 1, 2, 3. So you can say 1, 2, 3, 4, 5, 6, 7, 8. So you have 2 unpaired electrons. So you can say in this case, C has minimum, then you have D, then you have, no, C has minimum, after that you have B, after that you have D, and after that you have A. So A, D, B, C. A, D, B, C, that means C will be the correct answer here. Okay, done? Beta, I also need some motivation, na? You tell me, right? Acha. Now let's talk about this one, the number of isoelectronic species. Again, 2026 question here, that is number of isoelectronic species. Isoelectronic species means where the number of electrons are same. Among these is N. If N moles of EgCl is formed during the reaction, oh my god, what a question, right? Nice. First you have to tell number of isoelectronic species. Iso means same number of electrons are there, right? So if I talk about this one, scandium is actually, now let's firstly calculate the number of unpaired number of isoelectronic species. Okay, let's talk about number of isoelectronic species here. Yes, everybody, let's see. So scandium is actually 21 atomic number. You lose 3 electrons here, this will become 18. Chromium is actually 24, you lose 2 electron, it will become 22. Manganese is 25, you lose 3 electron, it will become 22. Cobalt is 27, you lose 3 electron, it will become 24. Iron is 26, you lose 3 electrons, it will become 23. So number of isoelectronic species are 2 here, right? So you can say N is equals to 2. Question is very interesting. N moles of EgCl is formed during the reaction of complex with the formula this. That means 2 moles of EgCl means 2 moles of Cl are outside. So this is cobalt, En is 2, number of NH3 will be 1 and there is 1 Cl here. So 2 into 2, 4, ethylene diamine is bidentate, so it is 4 plus 5 plus 6, right? Now this is the formula. Then they are saying number of electrons present in T2G of the complex. This is a complex. Now they are saying number of T2G. So this is 2, this will be plus 2, right? This will be minus 1, so it will be x plus 0 minus 1 is equals to plus 2, x is equals to plus 3. So cobalt in plus 3 oxidation state. Cobalt is actually 4s2 3d7. Cobalt in plus 3 oxidation state is nothing but 3d6, right? Now in this case what you have 3d6 electrons. Now very interesting question and very simple question. Now in this case what you will see that there is a strong field ligand, so it will cause pairing here. This will be 1 2 3 1 2. Okay, so you will have 1 2 3 4 5 6. So you will have 6 electron in the T2G. Is that clear or not? Yes, everybody, tell me. Is that clear? Is that clear? Yes. Answer is 6 is the correct answer. That was definitely not a difficult question, but it was a very nice question that they have compared isoelectronic species. The 3 things they have asked you, and all the things are simple only. So it is easily doable question, right? Then this is the 2025 question only. I have also done this before. Number of paramagnetic complexes that are here. This you can do yourself as well. Okay, this is your homework. This is your homework. This you can do yourself as well. Okay, this you can do yourself as well. Take a screenshot of this one. And I'll also give you the answer here. Just give me a second. I'll also give you the answer here so that you're able to see if you have answered it correctly or not, right? So there are 2 paramagnetic species here. Answer is 2 and you have to do it yourself, right? Because JEE 2025 question it is and there is no tricky thing here. Let's talk about this one. Let's talk about this question here. A transition metal among this that has highest standard electrode potential. It forms metal complex of the type this. The number of electrons present in Eg. Yes, everybody. Yes, everyone. Yes, everybody in the chat box. So, a transition metal among this has highest electrode potential. Highest electrode potential is of which one? See, if I tell you cobalt plus 3 to cobalt plus 2. Highest means it is very difficult to do that. Cobalt is nothing but 4s2 3d7. You take out 3 electrons, it will become 3d6. Plus 2 means it is 3d7, right? So here what you will see, wait a minute, this is plus 3 means this will become 3d6 and this will become 3d7. So this one has the highest reduction potential among all of them. Okay, now they are asking you if it forms a complex that is cobalt CN6 4 negative, what is the T2G electrons here? Let's see that. So if you say x minus 6 is equals to minus 2, it's plus 2. Now cobalt plus 2 is actually 3d7, right? Now if you see Cn is a strong free ligand, so here it will cause the pairing. So what is the electrons in Eg? 1, 2, 3, 1, 2. So I can see this is 1, 2, 3, 4, 5, 6 and 7. So how many electrons in Eg? There is one electron that is present in Eg. That is 1 is the correct answer here. Is that clear, everybody? Do let me know in the chat box if that is clear to all of you or not. Is that clear? Done? Done. Shall we move ahead? Now let's see the factors affecting CFSE. Factors affecting the charge on the metal ion increases with increasing charge. Now we are saying that if you talk about a metal ion plus 3 and plus 2, right, and plus 2 and there is 1 here, so definitely this one will have maximum CFSE. Whether the metal is in first, second or third row of transition elements, it increases with increase in ZF. Now we are saying that we can say that 3D has minimum, then 4D, then 5D has maximum CFSE. In fact, this is so high that they always cause pairing. This is so high, right? Then talking about the spectrochemical series here, this is a spectrochemical series. You should know it as it is because questions are asked based on spectrochemical series here. I have also given you a simple trick to remember this. I broke Samantha's clock. She found out called Harsha. Nobody ever noticed any cracked clock. Okay, so that's how you are going to remember, or you can have your own mnemonic as well to remember this. Now let's move to the questions part here. Which of the following correct order for ligand field strength? You can just see the strength, ligand field strength here, and answer is going to be A is the correct answer. This I have told you, 5D has maximum, then 4D, then 3D. Out of square, planar, octahedral, tetrahedral, this is the sequence. Now tetrahedral is almost, you can say tetrahedral is 4 by 9 of octahedral. It is almost half of octahedral. Okay, that we have written here, right? It is so small that usually it always forms, that means it is so small in the tetrahedral that it always forms, you can say this distance, if this is delta O, this will be half of it. Because of half of it, you can easily cause, that means easily electron can jump to the next level. That means tetrahedral, mostly it forms high spin complexes, right? Mostly it forms high spin complexes because delta value is so low here, right? Okay. Now let's see this. Crystal field splitting of this complex. This is again 2026 question here. New questions we have. The crystal field splitting of this complex is n times that of this complex. N is what? Right? Tell me everyone. Crystal field splitting they are saying is n times of that. N is what? Now here you have to calculate. You will have to do the calculation here. Right? Okay? Let's see. Then only you can compare now. So here you will have, this is cobalt, oxalato 3, this is 3 negative. So this is going to be, X is going to be plus 3. Cobalt is nothing but it is 4s2 3d7. Cobalt plus 3 is nothing but it is 3d6. Okay. In this case what you have, this is cobalt, this is chromium actually. This is chromium, this is oxalato thrice, this is 3 negative. So X minus 6 is equals to minus 3. Again X is going to be plus 3. So here chromium is in plus 3 oxidation state. That is, what is chromium? Chromium is 4s1 3d5. Plus 3 oxidation state 1, 2 and this will be 3d3. Right? Now in this case, if you see, this is 1, 2, 3, 1, 2. This is again 1, 2, 3, 1, 2. Okay. Oxalato, what we are going to do here, it will cause pairing. So this is going to be 1, 2, 3, 4, 5, 6. Here easily it will be 1, 2, 3. Right? So if you see the calculation part here, this will be multiplied by 0.6. Right? Done. Tell me. This is actually 3 by 5. So, sorry, this will be 0.4 and this is 0.6. This is minus, this is positive. So, I can say this is 6 into minus of 0.4, or you can say this is minus of 6 into 0.4. That is what? 6 still series 24. 2.4. This much. Okay, because EG does not have any electron. Again, this is minus of 0.6, this is plus of 0.4, right? Ulta I am writing, wait a minute, this will be 0.6 because this is less now, so this will be 0.6, okay? This is more, so this will be minus, always this is like, so this is minus of 3 into 0.4, 4, 3, 12, so it is 1.2. So they are saying that you have to find the value n times. So this is how many times? 2 times. So n is going to be 2. Okay. This part is 2 times this part. That means you have to multiply it by 2. Only then you will get this. So answer will be 2 is the correct answer here. Is that clear, everyone? Now let's see the relationship between strength of ligand and delta. We know that energy is equals to Hc by lambda. So that is why energy is inversely proportional to lambda. Right? So if they ask you the value of lambda, that will be inverse of the energy that you have in the spectrochemical series. For example, in 2026, this year Jan attempt, they have asked a question that is, consider the transition elements manganese, chromium, iron and cobalt, these 4, and all form low spin octahedral complexes. We are saying all of them are forming. Low spin means pairing they are causing. That means pairing is being caused, pairing is done. That is why low spin they are forming, na, because pairing is causing. The correct decreasing order of unpaired electron in their respective d orbitals is what? See, if you see manganese, manganese is actually 4s1 3d, 4s2 3d5. So 2 here and 1 here, this will become 3d4. Manganese plus 3 is 3d4. Chromium is actually 4s1 3d5. You take out 3 electrons here. This will be 1, 2, 3. This will become again 3d, 1, 2, 3, 3d3. Okay. Iron is 4s2 3d6. You take out 3 electron, it will become 3d5. Cobalt is +3. You take out, this is actually 4s2 3d7. You take out 3 electrons, it will become 3d6. Now see this here, when you're causing pairing, this is 1, 2, 3, 4. This is 1, 2, 3. This is 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, 6. They are saying decreasing order of unpaired electron. This is n is 0. Wait a minute. They are saying consider the all are forming low spin octahedral complexes. Not like this. Wait a minute. I'll just 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. How do I write it? Wait a minute. I'll just split it into parts. 1, 2, 3, 4. Okay. Now see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now see the electrons here when I am filling 4. 1, 2, 3. Pairing is there. So this is here. 1, 2, 3 only. Here it is 1, 2, 3, 4, 5. Here it is 1, 2, 3, 4, 5, 6. So here electrons are 0, here electrons are 1, here electrons are 3, here electrons are 2. So maximum electrons are in chromium, that is 3. So that is going to be +3. Right? After that you have manganese. Okay. After that you have iron, and after that you have cobalt. So answer will be A is the correct answer here. Okay. Done. Done, students? Clear? Answer will be A is the correct answer here. Next is crystal field stabilization. Again 2026 question, that is of this is greater than this. Okay. They are saying CFSE of this complex is greater than this complex. CFSE if I talk about, right? CFSE if you want to talk about, this is chromium +2. Chromium means this is going to be 3d4. Okay, +2 means 1 electron, 2 electron, 3d4. This is chromium +2, that means 2 electron, this is going to be 3d5. Okay. Now in this case you will have 1, 2, 3 and 4 electron, 4th electron here. In this case you will have 1, 2, 3 and 4 and 5. Here this will be 0.4, this will be 3 into minus of 0.4 plus 2 into 0.6. This is going to be 3 into minus of 0.4 plus 0.6. So here the subtraction, what you are subtracting, so if you see this here, this is going to be 6 to 12, this is 4, 3, 12, this will cancel out, this will be 0. This is 1.2, this is plus of 0.6, this is minus of 0.6. So definitely we can see CFSE of this complex is greater, right? If we talk about the magnitude here, right, that is 0.6, right? Now what about this one? Potassium ferricyanide has a greater spin only magnetic moment. Yes, everybody, tell me. Now consider this. Potassium ferricyanide. So potassium ferricyanide you have, and this is sodium ferricyanide. Okay. Potassium ferricyanide they are saying has more spin only magnetic moment. Right? Okay. So potassium, I'll just write it here. Potassium is what? Potassium Na3 ferricyanide. Okay. This is potassium. Wait a minute. This is potassium. Potassium. And this is sodium ferricyanide. Sodium ferrocyanide. See, if here I am talking about ferricyanide, that means this is +3 and this is already -6. That means this is going to be overall -3. That means here it is going to be +3. That means here it will be 3. Here if I am saying ferrocyanide, that means this is +2. That means overall +2 - 6 is -4. So it is -4. This will be 4. Okay, so that depends upon whether you have ferricyanide or ferrocyanide, you are going to give the charge here, right? Now, next is, if I see this is iron, ferricyanide means this will be in +3 oxidation state. This will be in +2 oxidation state. +3 means you will take out 2 electrons and 1 electron. This will become 3d5. 2 electrons you will take from 4s, because see, iron is 4s2 3d6. 2 electrons you take out, this will become 3d6 here, right? Now the next part is, this has greater spin only magnetic moment. See, if you talk about, this is a strong field ligand, so 1 2 3 4 5, so 1 2 3 4 5. Okay, again here also 1 2 3 4 5, so 1 2 3 4 5 6. So here number of electrons are 0, here number of electrons are 1. So this has more spin only magnetic moment, that is also true. So both the statements are true here. ठीक है जी? Okay. Tell me everyone, is that clear? Is that clear? Right? Now let's talk about the next question here. That is also very interesting. Very interesting question of 2026 here, that says, a first row transition metal does not liberate H2 gas from dilute HCl. They are saying it does not liberate H2 gas from dilute HCl. 1 mole of aqueous solution of MsO4 is treated with excess of aqueous KCl, and then H2S is passed. Now they are saying that the first row transition it does not liberate H2, and that we are talking about copper. Okay, they are saying CuSO4 is treated with excess of KCN. It forms CuCN. Okay, it forms CuCN, right? It treated with excess of this, and then H2S is passed through this. Now this will form CuCN4, right? Now this is not going to react with metal sulfide, you can say. This is going to react with H2S, then it is going to give you some metal sulfide. So now, because this is inside the coordination bracket, this is not going to react. No MS, no COS formed. There is no COS that is formed here. So they are saying the amount of MS that is formed here, that is going to be 0. Okay, that was also a very different question in your 2026 Jan attempt paper. Understood? Tell me everyone. Understood? Now let's talk about this further. Now they are saying colored complexes. See, colored complexes are formed because of DD transitions, right? If you have electrons here, right, the electrons is going to jump here, then move back, and it is going to give you complementary color here, right? And these are all the color wheel. We are saying that violet, if it absorbs violet, it will give you yellow. If it absorbs orange, it will give you blue color. If it absorbs red, it will give you green color. That is the color wheel that we have, right? Now let's see the questions that they ask you based on this. The wavelength of light absorbed for the following complexes, 2026 question. They are asking about the wavelength of light absorbed here, right? Wavelength of light absorbed. So that will be opposite to the, that will be absolutely opposite to the energy. So if I talk about this here, firstly I'll talk about the energy. Energy of which one will be maximum? Third will be maximum. Very strong it is. Third is maximum. Then you have ammonia, right? So that will be 1 here. After that it will be 4 here. Because it has ammonia with water, then there is only water, then there is this, right? So then you will have second, and the last one will be fifth, which has minimum. According to spectrochemical series, I have arranged it. Now lambda will be opposite. Third minimum, then 1, then 4, then second, then fifth. So answer is going to be 3, 1, 4, 2, 5. So answer is going to be C is the correct answer here. Okay, so that was a very simple question that we had, right? Quite a simple question here. Next is, next students, next is Statement is given to you. This statement they are saying this will absorb light of lower energy than this. The energy separation between two sets of d orbital is more than this. Now I think you can easily answer this question. I think very easily you can answer this question. Very easily. It's not a tough question at all. Right? 2026 again, Jan attempt, they have asked this question. COBr4 2 negative ion will absorb light of lower energy. Definitely, because it has low CFSC, you can say in spectrochemical series, it is low. So it will absorb light of lower energy. Iodine, the energy separation between two sets of d orbital is more than this. If you talk about iodine, right, in this case, no. See, it is actually like this. Iodine is a weak field ligand as compared to chlorine. So iodine should have low separation. That means the gap should be low. They are saying gap is more. That is false. Gap is less here, so this is false. So statement 1 is true. Statement 2 is false here. This is one of the easy sets where they have asked easy questions in JEE. Right? Okay. Let's talk about metal carbonyls, guys. Metal carbonyls, we talk about the synergic bonding here. So this is metal. See, usually metal donates its electron to the ligand. That is a normal case. But when metal is like, ligand is like you are donating electron. Wait. Sorry. Usually ligand is electron donor. So ligand usually donates its electron pair to the metal. Ligand usually donates. Ligand is an electron donor, metal is electron acceptor. But now metal is like, I also have electrons. Sometimes metal behaves differently. Sometimes metal is like, I also have electron, I can also give electron to you. So I will also give my electron, and it also start giving the electron, but it fills the electron in the anti-star, anti-bonding orbital of carbonyl. Okay, so that is called as synergic bonding, where it fills the electrons in the anti-bonding electrons of the metal. This diagram you don't have to do, just remember that it fills the electron in pi star orbitals, right? Okay, and now extent of bonding is always directly proportional to negative charge on the sentimental atom and inversely proportional to positive charge on the sentimental atom, because more the negative charge, more will be the donation by the metal. Due to back bonding, what happens? The strength of MC bond will increase. Now ligand is like, oh my god, what a beautiful metal here. He is also giving me electrons. I am so blessed. He is not only like, okay, too much clever, he is also giving me electrons. So bond will get stronger between metal and the ligand, right? That is, ligand here is carbonyl. Bond order of MC increases. If bond strength increases, bond order will also increase, but bond length is going to decrease because bond length is inversely proportional to bond order, right? If this bond or length decreases, then the bond length of CO will increase here, right? Okay, because what is there? Bond strength is directly proportional to bond order, it is inversely proportional to bond length, and MC is inversely proportional to CO. If I say the bond strength of MC increases, bond length of MC will decrease, so bond length of CO will increase here. Okay, and these are the some of the important structures that you have. Nickel form tetrahedral complexes, iron form trigonal pyramidal, chromium form octahedral complexes, then manganese form two octahedral complexes. Here it also have one manganese bond. Cobalt is very important. In this case, you have one cobalt bond. There are two bridging ligands and there are 6 terminal ligands here, right? 6 terminal and 2 bridging ligands here, right? Okay. Now let's talk about next question that was a little different than you expected to be, right? Okay. JEE 2026 question that was a little different question than you expected to be. Let's see that. Right, everybody? But a synergic bonding is back bonding. Okay. Yes, chalo. Let's see. Let's see this. Firstly, guys, what they are talking about, the statements that are incorrect about nickel complex of dimethyl dioxime are what? Firstly, you should know about this complex here. So what you have here nickel, right? And here in this case, you have dimethyl dioxime. Okay, what is dimethyl? Let's talk about that. So in this case, this is N, this is N. Firstly, I'll just draw the structure here, right? Dimethyl dioxime, right? This is N, this is O, H, O, H. Okay, this is the glyoxime part. Now I'll draw the dimethyl part. Okay, dimethyl part is this one. If you have, wait a minute, double bond C, this is CH3, this is CH3. Okay, double bond C, this is connected, and this is CH3 and this is CH3. Okay, so if I talk about one part here, this is actually one ligand. If you see, dimethyl glyoxime. Okay, this is glyoxime, dimethyl glyoxime. Now, what you will see here, the statements here, it is red in color. Firstly, they are saying the complex that is it is making, is it red in color? That is correct. It is definitely red in color. Then they are saying it has highest solubility in water at pH is equals to 9. That is not correct here. This is one of the toughest questions of JEE 2026, right? So it does not have, they are saying it has high solubility in water with pH is equals to 9 or pH is equals to 5 it will have, right? The nickel ion has 2 unpaired electrons here. See, if you see, this is a square planar complex, right? So if you talk about nickel here, nickel will have 2 unpaired electrons. Wait a minute, the complex contains 5-membered ring, that is also correct, right? N bond angle is almost 90 degree. NIN, this bond angle is actually, this is making a square planar, so this is actually 90 degree, right? So because this is making square planar geometry, right? So nickel ion has 2 electrons. For that we'll have to solve the oxidation state here, right? For that we'll have to solve the oxidation state here. Let's solve it, right? Let's solve the oxidation state here. If you see this here, in the glyoxime complex, there is 2 nickel 2. It is already given that nickel is 2. So you don't even need to calculate it here. Nickel plus 2 is always 3D8, right? So what you will see in this complex, they are saying it has 2 unpaired electrons. So because DMG is a strong field ligand, so you can say yes, okay? Because this DMG, dimethyl glyoxime, this is a weak field ligand. So this will not cause any pairing here. So I'll say 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. So it will have 2 unpaired electrons, right? So I can say this is also the correct one. So what will be the answer? This is correct, this is correct. BC, then N bond angle is almost close to 90 degree. So it will form DsP2 hybridization, that is for sure, right? So DsP2 hybridization, N bond they are asking. It is close to 90 degree, it will be 90 degree, that is true. But I am not having any option which is A, C, D, E. है ना? A, wait a minute. Wait a minute, just give me a second, just give me a second. They're asking incorrect kya? They're asking, acha, incorrect statements they're asking. Okay, okay, okay. Incorrect statements they're asking. Wait. Wait a minute. This will behave as a incorrect about nickel to DMG. Wait a minute. Wait a minute. Wait a minute. See, this is red in color, that is true. It has high solubility in water, that is false. Nickel has two unpaired electrons, right? Wait a minute. DMG is a strong field ligand. It is actually a strong field ligand. Just give me a second, okay? Hmm. Arre, my mistake, my mistake. Yes, it is actually a strong field ligand because if it is making DsP2 hybridization, then definitely this is acting like a strong field ligand. My bad, my bad. Okay, because here what will happen, because we can see it is making DsP2. That means it is sp2. So it will be 1, 2, 3, 4, 5, 6, 7, 8. So it is making DsP2. That is correct. DsP2, right? That it can make only when it has zero unpaired electron and it is a strong field ligand. That is correct. Okay, so I can say that is a strong field ligand. It is behaving like a strong field ligand here. Yes. Okay, so it has two unpaired electron. That will be false here because it will have zero unpaired electron. Then you will have nickel-nickel bond angle is approximately 90 degree because it is square planar. The complex will have five membered rings, five membered metacyclic metal containing rings. Wait a minute, let me see. Five membered is it? 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Two five membered ring we have, and this is 1, 2, 3, 4, 5, 6, and two six membered ring. I think in hurry I just did the complex. Acha, four they are saying. This is actually two five membered and two six membered rings. So this also becomes false. In hurry, I did mistakes, right? Don't do this in the exam, right? So here it is red colored complex. That is true. How many rings it has? Square planar geometry. It is a strong field ligand. All of this you should know. So answer will be B, C is the correct answer here. Okay, got it. And this was a very different question in your JEE 2026, right? Tell me everyone in the chat box, is that clear? Is that clear? Ha. My bad. DMG is a strong field ligand, right? Okay. Now, fatapat say let's complete structure isomerism. I'll hardly give 10 minutes to it, right? So if you talk about structure isomerism, ionization, hydration, coordination, linkage, ligand, and coordination position isomers are there. So ionization isomerism is that in which the counter ion and the ligand, it will exchange its positions. That is ionization. That means ions are different here. Hydrate isomerism is the number of water molecules behaving like a ligand are different. Here you have 6, here you have 5. In this case, linkage, you have bidentate ligands, like you have this. The donating site changes here. Then you have coordination, where two coordination complexes are there and they exchange their ligand, that is called as coordination isomerism. Now let's see the complex cation which has two isomers, the one that has two isomers. The complex cation which has two isomers, everybody, wait a minute. This will not do here, है ना? This will be done. अच्छा, two isomers they are saying, na? The complex cation which has two isomers. See, this will have two isomers, that is linkage isomerism. Okay, this will have the linkage isomerism, that is because of the bidentate ligand. So answer is going to be C. Okay. Then if I talk about ligand isomer is when the ligand is different, when the ligand is isomer of each other. Like this ligand, you can write it this way also, you can write it this way also. When the ligand is isomer of each other, two ligands are there and both the ligands are isomer of each other, that is called as ligand isomers. Coordination position isomer is when you have this kind of complex, two metals are there in one complex, and each metal, here you have NH4, here you have different ligands. Now here this cobalt and this cobalt has different ligands. When two metals in one compound you have and they inter-exchange their number of ligands, that is called as coordination position isomerism. Okay, then guys we have stereoisomerism, that is geometrical and optical isomerism. In this case, what we say that geometrical isomerism is only given by square planar and octahedral complexes, and optical isomerism is given by tetrahedral and octahedral complexes. That means tetrahedral complexes will not give geometrical isomerism and square planar will not give optical. Why? Because for geometrical isomerism you should have cis trans. Now in tetrahedral complexes cis trans is not possible because all the sides are symmetrical. If you see any tetrahedral complex here, I can't find it here, wait a minute. If you see any tetrahedral complex, okay, all the, even if you put it here or here or here or here, there is no cis and trans. This is opposite to this is next to this one also, this one also, this one also. So there is no cis and trans. And in the square planar geometry, why does not show optical isomer? Because always there will be POS present, always this POS will always be there. So for optical isomerism, we say that POS should not be present, only then optical isomerism will be shown by this, right? Okay. Now bidentate ligands are represented in symmetrical by AABB and unsymmetrical even like glycinato is represented as AB. Okay. Now see geometrical isomerism, right? Fastly we'll do. If you see AABB, right, those who want to do it in detail, I have 3-hour lecture based on isomerism in detail. This is just a recap. So if you see cis means two ligands are next to each other, trans means they are opposite to each other, right? Then for square planar complexes, there is no geometrical isomerism present in all these cases. In all these cases, there is no geometrical isomerism present. Now let's talk about the cases where GI is present. For example, Ma to B2. They are next to each other, that is cis. They are opposite to each other, that is trans. Okay. Then A to BC, A and A are next to each other, that is cis. A and A are opposite to each other, that is trans. Okay. Next is if you have MABCD. In this case, what you do, this is A, this is B, this is C, this is D. You fix one of them, then you exchange others. B and C is exchanged here. A is fixed, this is C, this is B, this is D. Now you exchange these two. This is fixed, right? Then you exchange this B here and this becomes D. Now if you see this here, when you fix A is already fixed here. A is already fixed here, right? Now what will happen here? What will happen here? A is already fixed. B, C, D, you are exchanging, right? Now if I say this here, if I take any two things that are same, let's say D and B are same. D and B are opposite to each other, that is trans. D and B are next to each other, that is cis. D and B are next to each other, that is cis. Now always, whether you take D and C as same or you take A and C as same or you take A and B as same, always there will be two cis and one trans here. Always. 3 GI will be present, 2 cis and 1 trans will always be present here, right? Then you have you have unsymmetrical bidentate ligand. These are opposite to each other, so it is trans. This is next to each other, then it is cis, right? Then in coordination number 6, in all these cases, no GI is present, right? In coordination 6, if you have A4B2, very, very important and very frequently they ask you this. In this case, when two same are next to each other, that is cis. They are opposite to each other, that is trans. Okay. Then you have very, very important, that is facial and meridional isomer. Facial isomer and meridional exist in MA3B3. When A3B3, when they are all next to each other, that is facial. When you have two next to each other, then leave one space and then you have the third one, that is meridional. Okay, right? I'm not giving you it in 3D. Why? Because we have already done it so many times. So I'm just giving you it in 2D. Okay. And A4BC, see, when these two are next to each other, that is cis, B and C. When these two are opposite to each other, because that is making a different isomer, that is regarded as trans. Okay. Then you have this is also very important. This also they ask you so many times. Okay. This they ask you, like they give you symmetrical ligand like En. Okay. And they ask you this. So when two En are next to each other, that is called as cis. When they are opposite to each other, that is called as trans. Okay, very, very important. This also they ask multiple times in your exam, right? Okay, so many times they ask you. This is a list of number of GI that is present here, right? So this is so this what is wait a minute. Achha, this is also we'll talk about this. Okay, don't worry. We'll talk about this. I'll just leave it here because now the flow is of doing things, right? So firstly, let's do and then solve the questions in the end. Optical isomer, you should not have POS present. POS should not be, plane of symmetry should not be present. That means you should have non-superimposable mirror images here. For example, if I talk about if there is optical isomer present, one will be dextro, other will be levo here, right? So one by one we'll talk about this. For coordination number 4, right? This now, if you don't learn it, you'll have to do a lot of things in the exam. So I would advise you just learn which one shows and which one doesn't show, right? So optical isomer is shown by MABCD because POS is not present here. This is important. Then optical isomerism in this case is shown by when you have unsymmetrical bidentate ligand, that also shows optical isomer. Others does not show optical isomer in tetrahedral, right? In coordination number 6, optical isomer is shown by 2-3 cases here. First is optical isomer is shown when you have Ma2B2C2, then optical isomer is shown here. If you have MABCDEF, then geometrical isomers are 15, optical isomers are 30. As it is, you remember. You don't have to go through this in detail. As it is, you remember, that is sufficient for you, right? Then let's talk about individually which one shows optical isomers. If you have AA thrice, that means three symmetrical bidentate ligands. This will always show optical isomer. For example, this is X, this is Y, this is Z, right? Now, if you take the mirror image of this one, this is X, this is Y, and this is Z, right? Now, ma'am, this is non-imposable. Ma'am, if you rotate, ma'am, it will be superimposable. How? If you see cobalt, 1, 2, 3, 4, 5, 6. Okay, if I rotate it to 180, this will become X, this will become Y here, and this will become Z. X is overlapping X, Y is overlapping Z, and Z is overlapping Y, so they are non-superimposable because X's are not same. So they are non-superimposable. That is why optical isomer is shown. This is very, very important. Next is AA2B2. This very, very important. It has cis and trans both. Okay. But only cis will show optical activity. Trans will not show. Trans will always have optical isomer. If you see trans here, here you have trans as well, right? This one. This shows optical activity. This will not show optical isomers because always there will be plane of symmetry will always be present here, right? So this becomes very, very important. This also they ask you so many times. Then if I talk about MAAB2C2, right? In this case, cis will show optical isomer, trans will not show optical isomer. For example, you have something like this: 1, 2, 3, 4, 5, 6. Okay. In this case, AA you have, this is cis means B and B are next to each other, C and C are next to each other. This will always show optical isomer. That means POS will never be present. But in this case, when you have B and B opposite, C and C, all there is this POS that is present here, right? So that is the reason it will always, so cis will show optical isomer here, right? That is also important. Right, everybody? Tell me, is that clear? Now let's do some questions on that. First is the Cl-COCl bond angle values in facial complex is what? Yes. So if you see this here, this is cobalt. Facial means 1, 2, 3, 4, 5, 6. That means if I draw NH3 here, this is NH3 here, this is NH3 here, right? This is Cl, Cl, Cl. They are saying Cl, CO, Cl. See, first thing is they can have this as 90 degree, they can also have 180 degree, right? This is 180 degree and this one is 90 degree that they have. So 90 and 180 degree they can have, right? Okay. Wait a minute. Facial meant meridional. I just made meridional. I think I genuinely need rest, guys, right now. My brain has stopped braining. Right, so this is NH3. Facial is when 3 are next to each other. Meridional, they will have 90 and 180. But in facial, they are all next to each other. So they will always have 90 angle. So answer will be C. So you can also draw it here. Okay, I can also draw it here for you to make you understand this better. See, facial means they will always be on the same face. Okay, so this is 2 and this is 3. This is the same triangular face. Okay, so 90 degree, 90 degree. They are 90 degree. This is also 90 degree. Okay, both are 90 degree to each other. Right? Next is we have, next is chiral complex from the following is, here is ethylene diamine. Chiral complex out of the following, that means optically active complex, optically active. See, if you see this here, trans will not be optically active here or here. Okay, trans will have POS. In case of cis, if I talk about this one, this is PT, 1, 2, 3, 4, 5, 6. En here, this is Cl, this is Cl. This will be optically active, that is the correct answer. What about this one? This is PT, this is Cl, Cl, NH3, NH3. This will also have, this is square planar, so this will always have, cis means this is square planar, and square planar is never, always POS is present in square planar. So optically active is not possible in this case. So answer will be A is the correct answer. Okay. Then what you have? Next is indicate the complex ion which does not show geometrical isomer. Indicate the complex ion which does not show geometric. I think you can easily do this. Yes, everybody. Indicate the complex ion which does not show geometrical isomer here. Yes, everybody. Which does not show geometrical isomer here. See, if you talk about GI, see, tetrahedral will not show GI. A3, B3, that can show GI. This is not correct. E5B, this cannot show. This will show GI again. Okay, this will also show GI. This is also show GI. This one will not show GI. We have seen this. This will show GI like this: 1, 2, 3, 4, 5, 6, 1, 2, and this is ClCl. And trans will also be present. Here also you will have facial and meridonial. Here also you will have metal 1, 2, 3, 4, 5, 6. This is same. This is trans. Cis will be formed when AA, BB, BB will be cis. So all of them shows GI except for B. B does not show GI. Okay. Next question is this year question. That is, let me see how many questions we are left with. We are left with 2 questions, guys. Let's see that. Firstly, let's solve that, or let's solve this. 3 questions we are left with. X is the number of geometrical isomer exhibited by this A, B, C, D. So geometrical isomer exhibited by this is N is 3. Sorry, X is 3. Because it has to always 2 cis and 1 trans is always present. Y, so this is going to be 3. Y is the number of optically inactive isomer exhibited by this. Inactive. Optically inactive. So you have metal. This has cis and trans both. Trans does not show any optically active isomer. So trans will not have optically active, but cis will have optically active. So Y is also going to be 1. So optically inactive means trans isomer of this will be optically inactive. That will always have POS. Number of geometrical isomer exhibited by this, that is 2. It shows facial and meridonial. So this is 2. So 3, 4, 5, 6. Answer is going to be 6 is the correct answer here. Tell me. Tell me. Yes, I'll take after this. Okay, don't worry. Okay, I'll take rest after this. Don't worry. Okay, next question is number of optical isomers exhibited by iron complex A obtained from the following reaction is what? Okay. Firstly, you have to tell what is the answer of this reaction. Okay. So you have Fe, you have oxalato, that will be 3, right? And outside will be iron here, right? Okay. Understood? Now if I see this here, if I want to have iron plus 3 here, this will be plus 3 minus 3. This will be plus 3, this will be minus 6, so it has to be minus 3. That means here it has to be 3. So that's how answer is going to be this. Now we are saying optical isomers. This is a condition of MAA thrice that always have 2 optical isomer, right? Non-super mirror images are possible, so answer is 2 is the correct answer here, right? Okay. Now let's see that one tricky question that we had here, right? Okay, that we were doing wait a minute. Because it was a lengthy question, so I left it in the end. Okay, so we'll see this. Yes, everybody ready for this question? Do let me know. Ready for this question? Ready for this question or not? Last question of today. JEE 2026 question again. They are saying this complex is a paramagnetic complex. Identify the incorrect statement. Okay. So complex exhibit geometrical isomerism. First thing is you have pH3 twice, and that is Cl2. It is a case of Ni, right? NiA2B2. So this is definitely, because this is paramagnetic, this is definitely going to show us geometrical isomer. That is correct. Okay. Wait a minute. This is a paramagnetic complex, na, they are saying. So we'll have to firstly make the geometrical isomer. They are saying this is white in color. Then they are asking spin only magnetic moment. For that also we'll have to calculate that. The calculation of CSC also you will calculate from there. Then they are saying the geometrical arrangement of ligands in the complex is similar to that of NiCO4. Okay? So one by one we'll have to solve it. Okay? One by one we'll have to solve it. Done everybody? Let's solve it. Let's see. Let's solve it. Right? Okay? First thing is PPH3 twice and this. So we have Ni, PP. I'll have to firstly see whether it is whether it's sp2 or sp3 hybridization. Without that, though, I can't answer whether it will show Gi or not. Right? So if I see x plus 0 minus 2 is equals to 0, right? That is x is going to be plus 2. Nickel plus 2 is going to be 3d8. Okay. Now, if you see this here, this is D, 1, 2, 3, 4, this is S and this is P. In this case, what you will see, this is a weak field ligand. So 1, 2, 3, 4, 5, 6, 7, 8. So this will give you sp3 hybridization, that is tetrahedral. Okay. Now, because it is tetrahedral, like number of unpaired electron are 2, tetrahedral. So tetrahedral never shows Gi. So this is a false statement. Okay. Then complex is white in color. So if I see this here, here you have unpaired electron. That means DD transition is possible. If DD transition is possible, that means definitely the complex will have some color. Okay. So complex will have color means this is also false. Calculated spin only magnetic moment of the complex is 2.84. Yes. If you see number of unpaired electron is 2 here, right? We can see this here. Number of unpaired electron is 2. Mu is going to be 2.8. That is also correct. Okay, that is correct. So answer the calculated CFSC of nickel in this complex is this. Now you'll have to calculate the CFSC here. Okay. So if I see CFSC 1, 2, 3, 1, 2, it is a tetrahedral complex. Oh, thuk, 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 again it has started. Okay. So this is a tetrahedral complex. It should be 1, 2, 1, 2, 3. Okay. So total 8 electrons you have. 1, 2, 3, 4, 5, 6, 7 and this is 8. So that means here you will multiply it by minus 0.6. This is plus of 0.4. So this will be 4 into minus of 0.6 plus 4 into 0.4. Okay? This is going to be 0 actually. Okay. So answer is this is also false. Right. Then geometrical arrangement of ligands in this complex is similar to that in NiCO4. So in NiCO4, what was the geometrical arrangement? In NiCO4, you had, this was 4s2 3d8, right? So it was a strong field ligand, so it was fully filled, but the hybridization was sp3 only. So this is also sp3, so geometrical arrangement is same. So this is true. So I can say, see everything they have asked in this question, right? So answer, they are asking the incorrect statement. So incorrect statement is A, B and D. Okay. So answer will be B is the correct answer, this one. Okay. So they have asked everything here. Okay? They have asked hybridization, they have asked CFSC, they have asked to calculate the magnetic moment, they have asked DD transitions, they have asked geometrical isomer. Okay, so they have asked everything here in this one question, right? So right now what I feel is doing the PYQs is very, very important for you. PYQs of 2026, so that's why I have taken all the PYQs of 2026 of coordination chemistry and chemical bonding, so that you know what they are asking, right? Okay, so you can see for yourself, I have taken very less time in theory part. Like I have theory part, so I have not even given importance, right? So I have taken majorly time, I have given major time to the questions, right? So you will see chemical bonding and coordination I have completed. 2026 latest pattern PYQs also we have done, right? You know what they are asking in coordination chemistry, in chemical bonding, especially in coordination chemistry. They are asking very interesting questions. They are asking statement. They will give you 5-6 statements and which of the following is true, which of the following is false, these kind of questions, right? So major focus is on that. If attempt 1 was like that, and if you think attempt 2 will be suddenly easy, no, right? So be prepared for statement kind of questions in inorganic chemistry especially, and even in organic chemistry you should be prepared for that. Might be earlier organic was easy, now organic will be tough, anything can happen, right? Okay, yes. Session PDF guys will be provided to you in the description box, right? I'll just update it. Okay. Okay, chalo. Now I'll actually my health is not fine, right? So I'll see if on Monday I need some rest. If I'm fine, then I'll definitely take your class on Monday at 12 p.m. Right? If my health is not fine, then I'll reschedule it. Otherwise, the class will be at 12 p.m. Now tell me in the comment section if you want me to take the class for full block chemistry, or do you want me to do P block and DNF block differently? Tell me. Or do you want me to pick only the questions of block chemistry? I can also make a session where we only go through the questions of block chemistry. That will also help you a lot, because theory is not as such there. There are questions only, right? So how do you want me to do? You can let me know. We can also do block chemistry PYQs, right? Okay, we want full block chemistry. Okay. Differently, block chemistry. Chalo, I'll just give you a poll here. You tell me what you want, right? Block chemistry, or you want it differently? Block chemistry. Block chemistry, na, then I'll pick only PYQs, right? Little bit theory I will do, very less theory and more will be PYQs there. Okay. P block, DF block, separate. Let's see. Accordingly, I'll make the session for Monday. Ma'am, block chemistry combined PYQ focused. Okay. So I can see most of you are saying block chemistry. Great. Great. Block chemistry can get little boring doing it differently, but chemical and coordination is so good that we have given it different time. So block chemistry, I can see 65% are saying block chemistry. Now see, block chemistry doing 2 chapters, that too big chapters in one go, and that too these many times is you will also get bored, okay? So do you want me to do it, ma'am, recap and, okay, so I'll do very little theory. Theory will be very less here, like very shortcut theory, maximum PYQs will be there, okay? You will say like 10-15% will only be the theory. Don't expect that I'll come here and teach you NCRT line by line and theory and all. I have already done that. You can watch that. But I'll do majorly focus on the PYQs, okay? Because in block chemistry, PYQs are repeated. They will not generate a new exception, okay? So that way we will do. Chal, okay. Okay, so Monday, I hope so I'll be fine only. Then I'll take your class at 12 p.m. in the morning. Fine? Chal. Okay then, bye. Bye-bye guys. Take care. See you all in the next class. Bye-bye.